So today we're going to learn about limits. What is the limit of a function? To better understand limits, let's look at the function to the right. Let's call this function f. Okay? So we have the function f that looks like a parabola facing down. What is the value of the function at x equals 0? So what are you going to do? From pre-calc, you know that you are going to look for the x equals 0 and then look where it hits your graph. In this situation, you know that what we are asked is f of 0 is equal to 4. Okay? So now we're going to change the question. What is happening to the values of the function at x approaches 0? So what it means is this is my function, it's walking, getting closer to 0, and here it's where it's approaching very close to 0. Okay, so both of my fingers, they meet where? At 4. Okay, so you know that the values of the function okay, approach to 4. Okay, so these are two different questions, as you can see. If the first we were looking for f of 0, the second one, it's not asking for the value, but rather the value of the function as it's approaching, as x gets really close to 0. Okay, so we call this the limit. The limit, it's going to help you to understand the behavior of a function as inputs approach a specific number. So today we're going to learn about limits, where the value of a function determines the exact location of a point on a function. The limit of a function asks what is the value approaching as we get closer to x. We can think of the value of a function as the house in the picture on the right. Okay, so we can think of the limit as the road that it's over here, that it's leading us to the house. Of course, ideally we would like for the road to lead us to the house. We will talk about that later. Okay, so the value of the function versus the limit of the function, specifically in the notation, it's going to be quite different. When in pre-calc and algebra 2, what you were always looking is f of a, where a is an integer number. Okay, instead here in calculus we're going to be focusing on this part, the limit when x approaches to a of f of x. As you can see, the notation is quite different. So this one is the one that we're going to be talking about for the next few days. Okay, so let's move on to the next example. Now, take a look at the next function. Okay, so you have it here. What are you going to do? Well, let's read the question. What is the value of the function at x equals 0? So basically here, if we call the function again f, they are asking for f of 0. Okay, so f of 0, you know that as you were doing back in algebra 2 and pre-calc, you were looking for the 0, the x0, and then you were looking where you hit your function. In this situation, you know that your f of 0 is going to be that number, which is -2. Okay, now the difference here is what is happening to the values of the function at x when it approaches to 0. Okay, so when it's approaching, this is my function, so I'm getting closer and closer to 0, approaching to 0. So here I'm approaching to 0. So what is that value? That value, it's this one over here, which is going to be 4. Okay, so as you can see, these two numbers, they are not the same. If they are the same, we're going to talk about continuity later, and they would be continuous. In this case, it's clear that the function is not continuous. Okay? How do we write a limit? Well, we write a limit like this. Okay? Specifically, you have that lim x that approaches to a of f of x. Okay? As we approach to x, what is happening to the value of the function? That's the main question. That's what you are reading when you're reading something like this. Okay? So when you have two sides of a value, okay, for a limit to exist, we need to look at both sides of this value. This is called talking to the left hand limit and the right hand limit. Okay? Please note that for y equals f of x, the value at x equals 2 here, as you can see, does not exist. Okay? Does not exist, it means that f of 2 does not exist. Okay? Now, If we are talking about the limit, it's different. Why? You are going to tell me what is this little hat that the 2 has. The negative, it means from the left side. Here is the left side, okay? So when I'm coming from the left, where my limit is approaching of this function f of x, you know that the limit of this function is going to be what? 4. Why 4? Because that's your output, okay? Now, when you see this little hat that it has a plus, okay, with the 2 again, the limit when x approaches to 2 from the right side, it's going to be again from the right side to that point that you care, that in this case it's 2, reach at the output, and you have 4 again. Okay, so as you know, both of them are equal. Okay, since both are the same, we would say that the overall limit when x approaches to 2 of f of x is equal to 4. Okay, this is what we call the actual limit. Okay, and when we say that the limit exists. Okay, so the rules for a limit to exist, this is quite important. The limit exists only if the left and right hand limits are the same. Okay, if they are not the same, then your limit does not exist. But if you have this situation, a situation like this one, you know that the limit at, in this case, c, it would exist. Okay, so let's look at another example. Okay, so this is a really cool graph, as you can see. I like it because it has several discontinuities here, as you can see. Okay, so we're going to use a graph of f of x below to answer the following questions. Okay, so here they are asking you directly f of negative 3. What are you going to do? You are going to look for your x equals negative 3. So 1, 2, 3. This is your f. Your f of negative 3 is going to be where you hit the graph, which is over here. So you know that this one is going to be what? 0. Okay? Because your output is 0. Okay, now look at this one. The limit when x approaches to negative 3 from the left side. Okay, so negative 3 is over here again. From the left side, I'm seeing that it's approaching to 0. From the right side, what's going on at negative 3? It's approaching to 0 as well. Therefore, overall, since these two are the same, what can I conclude? That this is 0 as well. Okay? So, as you can see, everything is equal to 0. Therefore, this is continuous. Okay? Now, let's look at another situation. Okay, here you have the negative 5. But the negative 5 has this little negative hat, meaning we're going to be looking for the limit when x approaches to negative 5 from the left. Okay, so from the left, you are like, oh, this is negative 5. Okay, so from the left side, you know that the limit is going to approach to what? Negative 1. Okay, now, if I ask you exactly the same, but the little 5 has, and the hat has the plus, it means that I'm asking for that negative 5, the limit when x approaches to that negative 5 from the right side, meaning I'm going to look from this side, so that one is going to be 0. Okay, now, if I ask you, find the overall limit when x approaches to negative 5 of f of x, what are you going to tell me? Well, these are not the same, therefore, does not exist. Okay, and that's why I write D and E. Okay, does not exist. Now, the last one that we have is f of negative 5. F of negative 5, you know that it's a simple function, so obviously it's not going to be this one because it's open. You are going to look for the shaded one, so it's going to be negative 1. Okay, so is f of x continuous at x equals negative 5? Okay, so what do you see here? Is it continuous? Clearly it's not. Okay, so no, it's not continuous. Why in this situation is not continuous? Because there's a jump discontinuity, what we call a jump discontinuity. Okay, there is a jump discontinuity. Okay, now, is f of x continuous at x equals negative 3? Okay, so let's look at negative 3. At negative 3, it was our first case where everything was the same, and we're going to say absolutely. Okay, why this is true? Because, okay, the limit from both sides, since I'm running out of space, okay, for both sides is the same, okay, and the function evaluated at that point at, what was it, -3, is the same, okay. So that's why, okay. So because everything was 0 at the very beginning, okay. So and it could be another number, but they need to be the same, okay. The four things, they need to be the same, okay. So is f of x continuous at x equals -2? Explain. Okay, so first let's look at x equals -2. Okay, so this is -2. Okay, what's happening here? There's a hole here and we have the point here. Okay, so what do you think? Do you think that this is continuous? And what your gut is telling you, I'm sure it's telling you no. Okay, why it's not? Because this point, it's missing. Okay, so there's a point, what we call, there is a point discontinuity. Okay. Okay, let's look at this example. I just made up this example just because. Okay, so this is my function f. Okay, so use the graphs of the function f below to determine whether the limit exists at the given value of x. Justify. Okay, so what are you going to do? Okay, so we have that we are looking for the limit when x approaches to 2 from the left. Okay, so we count 1, 2, here's the 2. Okay, so let's mark the 2 there. Okay, after that you are like, okay, from the left is this side. Okay, so my limit is going to be what? Well, apparently it's 2. I know that it's huge, that thing, but it's 2. Okay, now let's look at b. Let's look for the limit when x approaches to 2 from the right side. Okay, so what happens to the right side? Okay, so it's going to be -3. Okay, so what's going on with this limit? Does it exist or not? Are they the same? No, they are not the same. So this limit does not exist. Now, can you find f of 2? Yes, this is shaded, so this should be -3. Okay, so in this case, what's going on? Identify the values of c for which this value exists. Well, there's a lot that it exists. It exists all the way at 1, 0, everywhere, okay, from here up to -infinity, and basically it exists everywhere except at 2. So basically the only problematic number that this function has is 2. So the values where the limit exists, I would write it like this: -infinity, 2, union 2, infinity, right? All the other values, the limit exists because the function is continuous, but at 2 I have a broken piece, so I cannot fix it, and that's not continuous. Okay.